Now let's look at example 24 on page 156, and here we're being asked to solve the same problem two different ways. They've asked us to graph two lines, two linear functions, and we know they're linear because they're in the form y equals mx plus c. So this is in the form y equals mx plus c, and this one is also in the form y equals mx plus c. So we know they're straight lines, and we're asked to graph them in the domain. So the input values, x values between -1 and a +5. So let's go ahead and do that. Draw graphs of our functions, and we know that the x values have to go between -1 and +5 and no further. We have a restricted domain. I'm going to use two boxes to leave me space to verify my answer algebraically. So we've got -1, 0, 1, 2, 3, 4, 5. That'll be my x-axis. And then my y values, I'll use two boxes for them as well, to make it easier to read. And how far up and how far down do I need to go here? Well, it's not exactly clear, and if you get it wrong, you can always come back and fix it again. But there is a hint in the question. My constant tells me my y-intercept. So I know that my y values have to at least go between -3 and 1, and a +1. But I want to go a little bit further than that to give me space to draw out the full graph. So we've got -1, +1, 2, 3, 4, 5. So the x values come from here, and the y values are coming from my y-intercepts over there, but I'm giving an extra little bit of space as well to keep going with my graphs. Plotting them, I can find 2 points, or I can use my slope. So for f of x, I know that y is equal to x plus 1. So m, my slope is 1, and my y-intercept is going to be at y equals 1. Now a slope of 1 means my rise over run is 1 over 1. So every time I go over 1 unit, I must go up 1 unit. Over 1 unit, up 1 unit. If you don't like doing it this way, you can feel free to go ahead and find 2 points that are on the line and to graph it that way instead. But because it was already in the form y equals mx plus c, this seemed like a nice and quick way to draw it. So there's my graph of f of x. And again, we'll just write the name of the line. So this is f of x equals x plus 1. There's my first line. My second line then, I'm going to do it also using the fact that y is equal to mx plus c. So g of x, they gave me y equals 2x minus 3. So my slope is 2, which means my rise over run is 2 over 1. And both of the slopes are positive, and my y-intercept is at y equals a -3. So down here. Now this slope, rise over run, every time I go over 1, I go up 2. Over 1, up 2. Over 1, up 2. You don't have to do lots of them. Just doing it once is enough, but sometimes following the pattern makes it a little bit easier to graph it. And I'm going to join these together, join these points together, and find out where they have the same values, where they have the same outputs. So going through all of these points, sorry, unlock the camera. And and I can find my point of intersection. The point of intersection is where they cross over. So here's my point of intersection, and it looks like the point 4, 5. So there's my point of intersection. The point 4, 5. Let me label my G graph as well. This is g of x equal to 2x minus 3, just to make it nice and clear. Is that correct? Well, it probably is if I have drawn my graph correctly. Have I drawn my graph correctly? Well, we can verify our answer algebraically. So, point of intersection in algebra means simultaneous equations. So point of intersection and simultaneous equations are synonymous in maths. Simultaneous equations. What are my two equations that I'm solving simultaneously? My first equation is y equals x plus 1. And my second equation is y equals 2x minus 3. So I'll solve these simultaneously. I think I'll do equation 2, take away equation 1. You can do it differently if you want to. So equation 2 is y equals 2x minus 3, minus equation 1 is minus y equals minus x minus 1. The y's cancel, leaving me with 0, equal to 2x minus x is x, minus 3 minus 1 is minus 4, and solving that, x is equal to 4. Well, that seems positive because that matches the x value on my point of intersection there. And we'll sub that back into, it doesn't matter, but equation 1, y is equal to 4 plus 1, so y is equal to 5. And indeed, that matches exactly my point of intersection. So this gives me the point 4, 5 as my point of intersection. And I feel happy with that. It's a bit time consuming drawing the graphs. I think the algebra is quicker, but you can of course be asked to do it both ways, and you need to be able to do it both ways.